All right, hello everybody. We're going to get into the last topic for Unit 4 today, and that's going to be watersheds. This is a pretty straightforward topic. We're going to talk about how water interacts with the geosphere and how some freshwater aquatic biomes like rivers and streams and ponds and lakes form due to different factors that occur in the watershed. So a watershed is defined by the drainage into a common area. So every single fresh body of water, rivers, streams, lakes, ponds, they're all going to have their own watersheds. And what a watershed is, it's just all of the area that has runoff or percolation into that body of water. So for example here, we have this river that runs all the way up to here. And any precipitation that occurs in this light green area is all going to run off into this single river. So all of this light green area, this would be considered the watershed, okay? So anything that occurs in this watershed is going to impact this river in some way, either through pollution, sedimentation, devegetation, whatever may be occurring, anything in this watershed boundary is going to affect this river itself. Now, when we talk about precipitation, just a reminder from Unit 1, precipitation can either become runoff or it can percolate. Percolate or infiltration is when it goes into the ground, and runoff is anything that stays on land. Now here we have our water table. If you remember, this is essentially a line between the saturated and unsaturated zone. So the saturated zone is any type of soil in which its pores are completely full of water. We did those water holding capacity tests. So if your soil is completely full of water, we say that you are in a saturated zone. The unsaturated zone are areas where there might be some water or maybe none, but there are air molecules or air space left for water to still infiltrate. And this area between the unsaturated and saturated zone is referred to as your water table. And water tables are important because they often determine the depth of local surface bodies of water, so those freshwater ecosystem. So you can see here we have a drop in elevation, and then we have some surface water here. This is equal with that water table. So if the water table were to drop, the surface water would drop as well. Now, any type of large body of water that is underneath the ground, so just groundwater, we're going to refer to these as aquifers. So you can see we have two aquifers here. One is considered unconfined, one is considered confined. Unconfined means it has a very large area in which recharge can occur. So any type of percolation that occurs in all of this area, it's going to refill this water table or this aquifer. So this is an unconfined one. Now, this confined one has very little areas in which it can be refilled. In fact, the only area is going to be this small section right here. Okay, so if you were to think of it from a pollution standpoint, let's say we had some sort of factory up here dumping pollutants into the ground, the unconfined aquifer would be much more impacted than the confined because the confined can only be impacted by pollutants through here. And these large layers of soil, most likely being clay, because clay doesn't really let things percolate that well, will protect this confined aquifer. Okay? Now, watersheds are going to have some defined characteristics, and each characteristic is going to kind of shape how that watershed affects local bodies of water. The first one is going to be area and length. So how wide or how long is your watershed? Obviously, the bigger the area, length, or width, the more water is going to infiltrate or run off into whatever body of water you're looking at. So for example, if you look at the Mississippi watershed versus maybe Huron River that's nearby, we have two very different sized watersheds. So the Huron River here in Michigan, while pretty large, isn't going to be nearly as impacted by activities as the Mississippi will be, just based on the size of the two watersheds. The next one is going to be soil properties. So what is the soil makeup? If you have more clay and silt, your groundwater is going to get refilled a lot slower than if you have a lot of sand. This is also going to impact things like flooding, locations of lakes and ponds and streams and rivers. So your soil texture will play a big role. The type of vegetation and the density that occurs there. One of the ecosystem services that trees provide is an extensive root system. These root systems can then decrease the amount of erosion that's going on. If you have higher erosion, that's going to increase your turbidity of your water. Turbidity is just a measurement of how cloudy or how dirty your water is. But also, trees provide another ecosystem service of shade. So having a lot of vegetation is going to provide a lot of shade, and then that shade will help moderate temperatures within the water. And a lot of organisms that reproduce in water are very temperature sensitive because they are ectotherms, which means they regulate their body heat externally. All right, and that's going to lead us to the FRQ. For this FRQ, I'm not going to make you do it. If you would like to do it, I'll leave it up here for a few seconds while I talk. But you don't have to do this because we're going to be wrapping up Unit 4 and starting Unit 5 next week. But if you'd like to practice, feel free to do so. Again, just a reminder, this is the last section in Unit 4. So after this, you are free to take the online exam.